All right, I think we can get started. So I think we're on air and ready to go. So I'll get started here. So welcome everyone. If at any time you can't hear us or you can't see the screen, please put in the chat window and let us know just so we can handle any technical difficulties as they come. But we appreciate everybody for joining us on this webinar today, and look forward to presenting on 24/7 real-time monitoring using GNSS. So today there's two presenters, myself, Riley Smith, product manager with the monitoring and tunneling group at Trimble, and I'll let Daniela introduce herself.
Yeah, hello, I'm Daniela. I'm working in the technical support team for monitoring and real-time network, but mainly focusing on monitoring.
Perfect, thank you. All right, so today we're going to talk about GNSS in monitoring, and we'll introduce why you would use GNSS, what use cases in monitoring, and some of the components in the system of the Trimble monitoring system, and also look at some of the different options that you can use in GNSS monitoring. And then we'll get into a hands-on demo, which Daniela is going to take the lead on, and I'm excited to see. And then at the end of the presentation, we'll talk about some resources and more information for you to get started on using GNSS in your next monitoring project. And then we'll leave some time at the end of the webinar to have a question and answer session. So feel free during the webinar to post any questions you have in the chat window, and we'll take time during the presentation as well as at the end of the presentation to answer those questions. And with that, we'll get into the material. So let's start with the why. Why do we monitor with GNSS? So first off, it's the highest possible accuracy over long distances. So if you have a long or a large site area and you need to get those kinds of accuracies, GNSS is a good item to be using for that. Also, when line of sight is not needed or is unachievable, if there's a variety of objects or material or even terrain that's in the way that an optical means, such as a total station, wouldn't be able to measure through, GNSS can be a replacement for that. And also, if you have reference stations that are many kilometers away, this will allow you to use GNSS with those stations. Another key element is continuous operation in all weather. So where you may run into issues in very low or very high temperatures, or in inclement weather, let's say high rain or snow, GNSS can essentially work in all conditions and continue to operate during them. And the other big why is high data frequency. So in T4D, we support up to 20 Hertz frequency of measurements, and it allows for faster alarming when possible. So now we'll talk about the T4D system for GNSS monitoring, and what are those components. So first we start with the GNSS receiver and antenna, and then we configure in T4D server and pass that data from the receiver into it for storage and data management, and then use Trimble T4D web for visualization, analysis, reporting, alarming, all of the deliverables that you're really looking for when it comes to monitoring. So now we're going to break up each of those individual components and talk about them. So we'll start first with the GNSS receiver. So in T4D, we support most Trimble GNSS receivers. The most commonly used in monitoring are the NetR9 TIM and the Trimble Alloy receivers, which you can see on the right-hand side. And with those receivers, there's primarily 3 antennas that are used, the most common being the Zephyr 3 geodetic, which is on the bottom left-hand side, the left of the 3 antennas on the bottom, and then the other 2 antennas going towards the right, the Zephyr 3 and the GNSS choke ring antenna. T4D also supports several non-Trimble GNSS receiver manufacturers. So if you have receivers already that you want to use for monitoring, that is possible. And here is some non-Trimble manufacturer GNSS that we support. And if you'd like more information on specific receivers, we can provide that information after the webinar. All right, so we've talked about the receiver piece. Now let's get into the T4D server. So in T4D server, you're configuring your receiver for how to process the data and how to make good decisions from it. So there's primarily two ways of doing that. There's the real-time GNSS, which provides faster reaction times after movement, but is limited to shorter baselines. So a primary example of this would be bridge monitoring, where you have movement that's happening in short intervals, and we need to know that movement in less time. While with the post-processing side, where we're using the stored raw data from the GNSS to create more accurate results. This is better for longer reaction times, or where you're expecting slower movement over a longer time. And also if you have longer baselines between receivers, this is the more useful processing technique. Common scenarios for this are in earth movements or geophysics, in areas where that movement might not be happening in minutes or hours, but maybe over days, weeks, months. And one key thing to note, and really a powerful capability of T4D, is that we can run multiple GNSS engines in parallel while in T4D. Now, breaking that out into a workflow, and we're going to cover this in the demo, is what we need to do to set up a real-time or a post-process workflow in T4D. So first you start with, in the device manager, configuring your GNSS receivers to bring that data into T4D server. Then using the synchronizer to take all of that data and pass it into the RTK engine, which is doing all the hard work to process it, and then into the integrity monitor, where we get some basic reporting and analysis of that data. But T4D web is where we're going to go next to the deliverables and the primary reporting piece. Now on the post-processing side, we have similar process. We're setting up the receivers, but we're also setting up the storage locations. Where are the raw data going to be held, and where are we going to access it from? And then instead of an RTK engine, we're using the post-processing engine in T4D to come up with those accurate results, and then into the integrity monitor once again. And once again, we'll be showing this in the demo as well, so it'll become a little more clear. So the last piece of the monitoring system is T4D web, and this is the real end goal, in my opinion, of what we're trying to get from monitoring, and that's the visualization and the deliverables from the data. So there's a variety of reports and ways that you can analyze the data in T4D, as well as analyze data from multiple sites and areas. So if you're not just monitoring one area, but maybe multiple sites, you can do that all in T4D. And here's an example of a real-time GNSS report. Another key deliverable is the alarming functionality in T4D. So we can configure alarms to inform key stakeholders of critical movement that's happening. So there may be a variety of people on a project that need to know, whether it's the geotechnical engineer, the contractor, whoever it may be, they need to know about this movement so we can make better, more informed decisions of how to go forward. And with that, I've talked enough. So let's get into the real exciting part of the demo, which is part of the presentation, I should say, is the demo. So I'm going to pass this over to Daniela, and she's going to show us some exciting stuff about receivers and T4D. So Daniela, you should get the presentation right here soon.
Yeah.
Perfect. And I can see your screen.
You can see?
I can see your desktop, yeah.
Yeah, okay, so I have to figure out which desktop to show. Screen.
While you're doing that, I'll just mention to the audience There is some information that we put in the webinar on the right-hand side. Well, it might be on the right, but the GoToWebinar screen, there's 3 different handouts which give you a little tidbit of information about T4D and a couple applications where GNSS monitoring can be used efficiently. So feel free to take a look at those after the webinar, download those, save them onto your computer, and hope they provide a little bit extra information for you.
Yeah. Can you see my screen with the Netta 9 now?
Yep.
Yes. Okay. So then I know I'm on the correct screen. Okay, so I start my demonstration the same as Riley did. At first, here I'm connected to one of the Netta 9s of the support team. I'm connected to the web interface of this Netta 9, and I want to give you a little introduction on what you can configure and see in the web interface. So this is the landing page, which shows the activity of the Netta 9. We see the currently tracked satellites and currently internal data logging session where we store internal TCO2 files. And here on this receiver, we already have 3 outputs available. And I want to show you how to create one more TCP/IP output and how to connect to this. Yeah. If we are looking at the satellites, we can see here some general information about the tracked satellites. We have satellite tracking information. We can also see the tracked satellites in the sky plot and enable or disable certain satellites. Data logging is configured here, but I don't want to change this now, but I'll want to show you the IO configuration where the connection to T4D server is configured. You see in green here the 3 active connections we have, and I want to connect to this port. This is port 5023, and I want to stream a RT7027 data stream to T4D, as this is the Trimble format for transferring data to the other softwares and like T4D. So here I have different options to allow multiple collections or some securities, but I don't want to use this now. So in the summary, you can see that I'm outputting RT27 data in a 1 Hertz interval. The Netta 9 itself is able to track and output up to 50 Hertz. In T4D, we support up to 20 Hertz, but for my demonstration, I'll use a 1 Hertz epoch interval now. So this is all configured, and I can open my T4D. Here in T4D, I need at first one parent module. Going to another screen? No.
Yep, we can see the T4D server.
Yeah, but it's only blinking. Maybe the box is. Very strange. I'll just reopen the user interface.
No problem. I'm just going to take a look to see if there's any questions while you do that. No questions so far, so we must be doing a good job of explaining things. So while Danielle is doing that, I do have a poll that I would appreciate if everyone can take a minute to answer, just to give us an idea of who's attending and your level of using GNSS with monitoring. So I'm going to launch that now, and we'll see if this works. So the question is, how many of you are using GNSS for monitoring right now? And a few options. If you're not using it, there's a couple options, and if you are, also a couple options. So curious to hear what the spread of answers is. Cool. Thank you for answering. I see we've got some activity. So everybody's still awake. Good. Awesome. So it looks like a pretty good split, almost 50% split of yes versus no, but a lot of you are interested in using it in the future, but aren't using it right now, and then a few in the yes category. So good to know that we've got kind of a mixed audience here. So I appreciate everyone for answering that. So just close that and make sure we send that back to. There we go. So awesome.
Okay, can you see my screen again?
Yeah, I'm looking at the receiver web UI.
The T4D UI, right?
Yep.
Yeah.
I can see T4D.
Okay. Yeah, so the first module we need for GNSS monitoring is the device manager module. And here I can just add the default settings. Here you could disable any satellite system, but I don't want to do this now. So the first module is loaded into T4D, and beneath this module, I can add my GNSS receiver module. I'll add a new one and call it now demonstration or demo. And the first thing I have to add here is that I have to select the station. The station I've prepared in an IGS site log file, which I want to upload now, and they are in this folder. In this IGS site log file, I've already, or it contains the name and the coordinates of the file, as well as the antenna manufacturer, antenna type, and also the receiver type. So I will add this to my system, and you can see all the information available here now with the position, the antenna, and the receiver information. If you don't have the position of your GNSS receiver or antenna available yet, you can either use another tool to process it. You can also use the Trimble RTX service where you can upload, for example, a TCO2 file which was stored on your Neta 9, and then you get a report by email with the accurate position of your receiver, and you can use this in T4D to calculate the first coordinates. So I'll select here OK. And we see here also again the manufacturer, and the decoder group is the next setting. Real time is the same as RT27 selected in the receiver, so I have to go with this. In the next step here, I have to enter the IP address of the Neta 9, and this was 10.2.156.252. And the port I've selected was 5023. So I select this. In the receiver data, I can define an elevation cutoff and again a tracking interval. And here you can see again that T4D is able to track up to 20 Hertz. Normally I'm using here now 1 Hertz. I could enable another internal data logging session in the NetR9, but I don't want to use this. I don't have an external sensor connected to my NetR9. And in this demonstration, I don't want to show storage integrity. Storage integrity is in general a nice feature if you have, for example, a communication problem and the TCO2 file or the raw data file stored on your server is not complete. T4D can connect to the NetR9 automatically and download the internally stored file from the receiver. So now the receiver is coming to T4D. At the moment, we see an explanation mark because it takes a little while until the orbits are available. We see here in the raw data analyze, okay. Now also in the sky plots that the ephemeris of the receivers are available, and now the icon shows the correct icon is displayed here. Yeah, we have several views here. For example, the satellite tracking view, a skyplot view, the receiving info. A multipass view is also available where we can show the multipass. This is calculated over time. So if the receiver is running for some time, it would be displayed all here where you have a lot of multipass on your station. Beneath the GNSS receiver, I will add a storage module. I'll use, in this example now, a TCO2 storage. We have different formats here available, like Rhinex, some older formats, or TCO2. You define a path where you want to store the data, a kind of folder structure. Enhanced day creates a new folder for each day, and you can also define again the data rate. Here you can define when a new observation file should be started. I'll choose 1 hour, so I have 1 file per hour. For the compression, I don't want to do this as TCO2 is already compressed. So here we see that the file is stored and we can see some history. With a GNSS receiver, T4D automatically adds a module called Ephemeris Manager. And here the ephemeris normally you have more than 1 receiver. The ephemeris manager takes the ephemeris from the receiver, the broadcast ephemeris, and also predicted or precise ephemeris, and forwards them to the processing engines. Yeah. Okay. For the next part, I want to use this demo system. So this is basically now also my second part here. I have already configured a device or a T4D system, and the system is running since over a week now. And I've configured here 3 receivers. The receiver Höhenkirchen is on top of the TerraSat office close to Munich. The station Hohenbrunn is around 3 kilometers away, and the station Sacklerstraße is only around 300 meters away. So it's next door. The device manager here shows an overview of the stations. We see the station name, ID, code, the receiver type, decoder, firmware, and the connection. The real-time processing needs 3 modules in T4D, a synchronizer, the RTK engine, and integrity monitor. The synchronizer takes the epochs from the GNSS receiver and sends the data as 1 epoch to the processing engine, in this case, the RTK engine. We have some views here where we, for example, can see the maximum delay and average delay of the stations. And if we want to troubleshoot this, we can also look at a station delay, where we can see that, for example, the close station has not that good internet connection and more delays than the green one and the gray one here. So here the delay is very slow. The RTK engine does the baseline processing. The library used here is basically the same library as, for example, used in TBC or other Trimble products, and yeah, it calculates baselines. Here we see the two baselines which are created. We see the baseline length, the position status, the solution, orbit. Yeah, now we see that we have a little outage probably in one of the stations. And we see also that we use the orbit mixed. In this case, I have also a ephemeris download module. And here I'm connected to the University of Bern to download ephemeris data, which is then used in T4D for the processing. We have here the option to connect to the University of Bern or to IGS to download the files. We have already the available predicted orbits, and you can also download the precise orbits. They are available after around 2 weeks, so I'm not using it here, but yeah, it is possible to do a processing in T4D in the post-processing engine using this orbits, but then we have a delay. No, I don't want to change any of my settings. The RTK engine, let's go to the view again, has here some options, and there are in general 2 processing modes. You can change them only when you insert the module, so I can only tell you the other mode, and that's the VRS mode. In VRS mode, we are not calculating baselines as a correction. We take data from a GNSS network, like for example from VRS Now. So we connect to an Entrapcaster, get correction data, and process the position of the station with the help of this corrections. Then we don't need any fixed station, but the backside is that it's normally, at least with shorter intervals, not that fast, or not, the accuracy is not that good. Okay, any questions? No. The RTK engine has a maximum baseline length of 35 kilometers, and I've selected here to not use redundant baselines. If I would change this to yes, also the third baselines between the stations would be calculated. I'm using all satellite systems. And in this RTK engine, I also called it like this, I'm not using any filter. We have different filters here in the RTK engine, a weighted mean filter or a Kalman filter. And I can show you this on this RTK engine. Here, I'm using a weighted mean filter of 10 minutes. And yeah, so T4D always calculates a weighted mean of the last 10 minutes. Yeah, we can see this in the chart view here. This is the results in the height of one of the baselines of the last hour. We can see here the unfiltered result, which are going up and down. And the filtered baseline here is much smoother. So filtering is something very good because the data is much smoother. but the downside of filtering is that if something is moving, it takes a while until the results show this. This is a screenshot of a test we did some years ago, and we moved in this 3 kilometer baseline one of our stations up for 10 centimeters. And you can see here that it takes exactly 10 minutes until the results show the movement of the 10 centimeters. In the baseline view here, we see the same. The unfiltered results show the 10 centimeters basically, yeah, after in the next 2 seconds, but the filtered results take 10 minutes again. The last module we need for the real-time monitoring is the integrity monitor. Here we are performing a least square adjustment, which is of course with only one baseline, not a real least square adjustment. Here I have a photo. Sometimes I'm building up a demo system like this. And this is also what I would recommend more, to have 2 fixed reference stations far away from the monitoring area. And here the green lines between the stations are the baselines. And here we are performing a least square adjustment. The current displacement show the delta northing, easting height, 2D and 3D, and also the sigma values. The integrity monitor has a simple displacement chart where you can see the result. Here you can always see the result of one of the stations. Yeah, Hohenbrunn didn't have an outage. Normally Sacklerstraße is not that stable. But yeah, for T4D Web, it's much better to use the charts or analysis in T4D Web to analyze your GNSS data. In the charts view of T4D Web, you can see a simple chart, like for example, similar to the chart in T4D server, and you can also create analysis. For example, here I've created an analysis which shows my 2 stations, and I selected to have a rolling window of the last 4 days. So I'm always showing the results of the last 4 days. I'm also showing some log types, which we will see later. I defined that everybody connected to T4D Web can see this analysis. And I defined here to show the 2 receiver, Sacklerstraße and Hohenbrunn, always in 2D and height. And I also defined some plot bands to show the alarming and so on. Here I'll pop up the chart to show the data.
So while that chart is generating, we have had quite a few questions come in. So one I think is a good question to ask. The question was around RT17, RT20, RT27. When you set that in the GNSS receiver web UI, is that information used in both the post-processing and real-time monitoring solutions?
Yes, I mean for real time this is used. For post-processing, we basically store the RT27 data later in the storage module, but I'll come to this in the post-processing part.
Perfect.
Okay. Now the analysis here is loaded, and yeah, we can see at first for example, here the results of Sacklerstraße. This is here, for example, the 2D displacements. And here you can see in the last 4 days that the variations are very low. They are beneath a centimeter. In the height, I changed yesterday the antenna height to simulate an alarm. So this is the peak you can see here. And here the server was rebooted, and I added this as a kind of log to T4D Web. And we can see in the chart here, when you are wondering why we have this outage, that I changed the server configuration. So this is the small baseline with 300 meters. This is the longer baseline to Hohenbrunn. Here we can see the height variations. They are often in the range of 2, 3, 4 centimeters. But looking at the 2D displacements, they are also much more stable here, around 1.5 centimeters. Yeah. Now, if there's no question to the RTK engine, I can start the part about the post-processing, or do you see any question?
There is a lot of questions, so
Okay.
well, maybe let's answer one and then we'll save the rest for the end. This one is in relation to the RTK engine. So the question is regarding the NetR9. So we know we can calculate a RTK position using the NetR9. Is the RTK engine in T4D the same as would be used with the NetR9, let's say with a different RTK position? So from, let's say, using a field controller or a different method?
Yeah, so I'm not sure about every Trimble controller, but for the NetR9, I know that internally also the same RTK engine is used. Yeah.
Cool, awesome. Yeah, well, there's some other questions, but I think we'll save them for a little bit later. And
Okay.
this is some really cool demonstration, so don't want to ruin your streak here.
Okay, so I'll go on with the post-processing part. So beneath my GNSS receivers, I have here also a TCO2 storage where I'm storing 1 Hertz data in 1 hour files. We can see the history that, here this station is complete. In the meantime, Hohenbrunn is also back. And we didn't had an outage a lot, but now we have some missing epochs for the outage we just had. So in the storage module, you have some properties with a folder path, folder structure, and the post-processing engine has basically the same settings. So you select the folder structure, the file type, and select which station should be processed. We can define here a start time. This is normally the time now. In the post-processing engine, you could also stop the engine and change the start time back for, I don't know, some months ago if you want to reprocess things. Or add another storage module with another interval, you can use this. We have here a session duration, which I'm also using here, the 1 hour. And in this post-processing engine, I'm using a session duration of 24 hours. I'm having a delay here for 2 minutes. This is mainly because the storage files are written after the hour, and it sometimes with the compressing takes a little bit so that we don't have a file conflict. I'm waiting for 2 minutes. I'm using a processing interval of 10 seconds. I used a maximum baseline length of 70 kilometers, but here we don't have any limitations. I think I processed up to 200 kilometers, and you can even allow to float solutions in the processing here. We also have a filter, but I'm not using this. So in the post-processing engine, we see here the also the baselines with the lengths, the orbit, and history of the baselines which were processed in the past. The integrity monitor is the same again. We see a map view, which gives the overview of the system, the current displacements, and a displacement chart. In T4D Web, I also created one analysis for the post-processing engine. Here I'm using the last 7 days, and I have 1 hour and the 24-hour sessions always in 2D and height. So looking at this analysis, we can see the results. I'll always show only one. So this is the 3 kilometer baseline to Hohenbrunn. Here we see the 2D results. They are around here. We had one outage here over a centimeter, but otherwise they are very stable. The height has more variations, around 2 centimeters, I would say. Sacklerstraße has a smaller baseline. Here in the 2D, we don't have this is here 2 millimeters, the variations here, and in the height, it goes up to 1.5 centimeters. Looking at the post-processing, we see really only a few variations, 4 millimeter or 6 millimeter in the height, and in this case, 1 millimeter maybe in the 2D. Looking at T4D Web is one thing we can do, but you can also, what I would recommend everybody is creating a report. T4D has several reports available, alarming report, analysis report, log report, sensor reading, and status report. And I have some predefined reports here. So for example, in this report, I've defined that I want to have every day a report at 8 o'clock when I'm coming to the office. Only I get the email, and here I want to see in this report the analysis of the RTK engine of the last day of the 2 stations and post-processing engine for 7 days. I think I created the report here. So every morning you get a report showing the displacements of the last day, the summary, the other station, and post-processing engine, in this case also the last day or the last 7 days. The report of the positional sensor reading sends here for, so I defined here a few things, but I'll show you this on the report I've created before the meeting. So here you can receive a report with the raw data. It sends, I selected now every column. Normally you would not have every column and select what you want to see, but you basically can see the sensor name, alarm state, data type. We have reference positions here, the observation date, northing, easting elevation, and also the calculated northing, delta northing, easting height. in T4D Web, we also have the possibility to calculate velocities, and they are also displayed here. Yeah. So this is a report with all the readings. The alarm report generates an overview, if I'm previewing this one now, with the alarms that are happening. At the moment, all my sensors are okay. And yeah, we even had a little alarm this afternoon looking at, I can show you here my alarm job. So I've created here an alarm job with, so every minute T4D checks if the sensors are above this thresholds. And yeah, we have a nice history view where we can see the alarms. So this afternoon or lunchtime, the alarm changed to attention. And we can look at the charts here to see that this time not the height was in alarm state, but here the Delta 2D, I selected it to 1.5 centimeters, and this was a short time above the alarm. Okay.
Cool. So with the alarms in the reporting, someone could set up that only reports or notifications are sent to a certain people, certain individuals, when that goes out of the threshold. And then you could also have reports that send to you every day just to notify if there is any movement or is the sensor working properly and receiving data. And so there's a variety of things that you can have automated. Is that correct?
Yeah,
I guess that's a question
that's
more
correct.
than a
And
statement.
I would really recommend having a report on a daily basis just to know, okay, the sensors are working, everything is fine, and to know your system.
Awesome. Cool. So there was some good questions, and maybe we have still quite a bit of time, so we can take a look at those. One of the questions, I answered this already, but I think it would be good to mention again. So at the very start of the demo, you showed a web browser, and that had the web interface for the receiver. And so the question was, is that what the receiver interface looks like for the NetR9? And the answer is yes. It looks very similar for essentially all Trimble receivers. Yeah. So if you're connected to a receiver, let's say over an Ethernet cable, and you put in the IP address in a web browser, it'll pull up that receiver interface, and you can configure some of the settings and data streams.
Yes.
Let's see. Oh, there's some more questions here. This is a good one. Is T4D using GPS L5 frequency in the processing? If you don't know, we may have to get back, or I can do some.
I
can look in the document really quick.
I guess we have to go back because I think yes, but I'm not 100% sure.
Yeah. So thanks for the question. That was from Jaideep. I'll get back to you with an answer on that. The receivers themselves can receive that frequency. I'm not sure at this point if we're processing it in the baseline engine or not, but we will get back to you with an answer on that. Thank you for the question. All right, so that covers most of the questions for right now. If anyone else has a question, feel free to enter that in the chat window, and we still have 10, 12 minutes. Would you like to show anything else in T4D server web, Daniela?
No.
All right, so let's talk about, let's see, hopefully everyone can see my screen.
Yeah, looks good.
Perfect. So we'll just finish up with kind of a summary of what we just covered, just to reiterate all of the great information here. So first was why we use GNSS for monitoring the different scenarios where you may use it. The Trimble monitoring system components. So we talked about those, as well as Daniela got into how to configure and set up the receiver, the antenna in T4D server, and getting out the data and reports and alarms in T4D web. And we also talked about the two different types of results that we can get, so the post-process versus the real-time GNSS, and the various outputs and deliverables that you can get from T4D for whatever type of monitoring project you may be working on. So some next steps for anyone that's interested. So if you are curious about T4D or any of the system components, we have a YouTube channel, so you can go onto YouTube and just put in Trimble monitoring. It should be the first result. And there's quite a few videos, some that have been done by Daniela that are awesome and very instructional.
Yeah.
And
the GNSS monitoring videos should be ready end of this week or next week.
Awesome. So we're more and more videos added every week. So you hear that? Great content. and also webinars. We've done a few monitoring webinars previous to this one. So those are all up on the Trimble Geospatial webinars, as well as any of the other general ones for any of the Trimble Geospatial products and solutions. And then if you are curious about T4D or monitoring solutions, feel free to reach out to your local Trimble distribution partner, and they'll be more than happy to give you a demo or to chat a little bit more about the system. As well, feel free to reach out to me on LinkedIn, and I'm always interested to hear from anyone doing monitoring out in the wild and to get some opinions. And a little stay tuned message. So for those of you who are interested in future webinars, we've got the next one coming up on July 15th, which we're going to cover geotech sensors in T4D. And then following that, the fifth webinar in our series in August will be covering kind of a deep dive into Trimble T4D web. So stay tuned for those. You can find those on the Geospatial webinar website and sign up for those there. And I hope to see you all there. And with that, thank you. And we'll take a few more questions because we did have a couple more come in while I was talking. So all right, so let's start with this one. So Dean, shout out Dean. Good to hear from you. I used to work with Dean a long time ago. Would this system be recommended for monitoring monuments with baselines at 500 meters? Would this system detect millimeter movements in horizontal and vertical?
Yes, horizontal, we saw this. Vertical millimeter in 500 meter baselines, you might have to use some filtering, and then yeah, you could get a little bit delayed alarms, but in general, yes.
Cool. Hope that answers your question, Dean. And then we had a question come in from Kent regarding what are the differences between Trimble T4D and the Pivot platform?
Yeah, the Pivot platform you may saw the same or looks the same as the T4D server platform. It's, yeah, the developers are the same, they share the same resources. Trimble Pivot platform has no T4D web. Yeah, that's basically the main difference.
Mm-hmm. And maybe from what I understand, the Pivot platform is more about managing multiple receivers in an area. Like
yeah, I mean, the Trimble
infrastructure.
Pivot platform is made to produce real-time corrections and outputs this to the rovers. You are able to add the RTK engine and the integrity monitor or the post-processing engine. but you don't have the web to analyze the data.
Very good. Thanks for the question, Kent. Alex asked to show the webinar agenda again, so I put it up on the screen, so hopefully that answers the question. And then there was another question coming from Samir. After any event, how can we quickly receive an alert to state that the threshold was exceeded? So if we have a sensor monitoring something and we've set those threshold tolerances, how can we quickly receive an alert that it's been exceeded?
Yeah, so you can receive the alert in T4D. In the alarming, we basically have three options. We send email, SMS, or run a batch file. And yeah, so yeah, you can receive this after around 1 minute. The email should be sent. You get two emails, one with just a simple chart. This value is above the threshold, and another one with the displacement chart shown here and some more information.
Mm-hmm.
But yeah, this
Did
is
Did you want to share your screen to show that? Yeah, I'm still showing mine, so I can switch it to
okay.
you.
Yes, we can.
That might give a little bit better better context to everyone on the call.
My screen.
Yeah, I can see T4D server.
T4D web.
Yeah, no. Yeah.
Okay, yeah. So yeah, you can define notification recipients. At the moment, only I get the results or the alarms. You can send in the administration, you can define what kind of results you want to have. So I decided that I only want to have emails. You can only get SMS, both, or web notifications, or in the alarms, you could also start a batch file to start some automatic process. I hope that answered the question.
I think it did. And then there was also another question from Samir about setting alarms for sensor failures, and I think that would be through a similar process. Is that correct?
Yeah, so here I defined, yeah, in general, I defined here that I want to have an alarm if I don't have new data after 12 hours. So in T4D web, you can define a no data threshold, and then you get an alert if your receiver is down. Yeah, you can also put this to 1 minute, but then you're normally spammed with emails.
Yeah. Cool. So that looks like all of the questions. Let me just take one more look to make sure I didn't miss anybody's question. We still have a few minutes. So Danielle asked, regarding the post-processing GNSS method in T4D, is it using static processing or PPK method, which is post-processed kinematic?
So we also have here the processing mode. So per default, it uses the processing mode static, and this provides then, in my example, in the 1 hour session, one result for the last hour. If you insert a new post-processing engine, you can also use the processing mode kinematic. I can show you this here. And then, yeah, after the hour, it would reprocess the file in kinematic mode to show the offsets. This is normally not used because then you could also use the RTK engine. In normal monitoring, this is more used if, for example, an earthquake happens and you know in this file there was the movement and I want to know exactly at which minute. You can reprocess the file in this kinematic mode.
Very cool. Well, more questions coming in. Such interesting material we have. All right, we probably have time for one more question. And this is from Borna. Is there a limitation on the type of receivers that can be used?
No. So no, this depends on the server configuration. I mean, T4D server is the same as the Trimble pivot platform. There we have systems with 200 GNSS receivers or more. In monitoring, I don't know a system above 20 receivers, but yeah, if you have a strong server, it should be possible.
Yeah, very good. Well, with that, I think we will close out the webinar. There is a few more questions, so I'll try to follow up with you after this webinar and answer your questions, but we appreciate everybody attending and being very interactive in this webinar, and thanks to Daniela for presenting on T4D, and I think we all learned a lot today, so stay tuned for the next webinar, which is on July 15th, and we'll be talking about geotechnical sensors in T4D. All right. See you, everyone. Take care until next time.
Okay, bye.